So in the first video, we were able to convert from moles to molecules or to atoms, and so we were looking at the amount of something as far as the number of molecules or the number of atoms. In this video, we're going to take a look at mass. Since mass is such a large part as well, all the different elements on our periodic table, we're going to be using mass a lot as well, especially when we have to measure these out on a balance and use them in class. So to kind of deal with mass and moles, we are going to taking a look at the atomic mass of our elements, and you'll need a periodic table. The mass of an element is also the mass of 1 mole of it. So on the periodic table, if you were to take a look, for instance, I'll do an example for carbon here in a second. We call this the molar mass. So the mass of 1 mole of an element is what the molar mass is, and this is the mass that we're going to be using from our periodic table. So now, for example, we have carbon 12. It's the most common form of carbon, and if you take a look at your periodic table, carbon has a mass of 12.011. Now we're going to be rounding to just the first decimal place, to the tens place, so 12.0, and that is equal to 1 mole of carbon. And we can do this for multiple elements. So hydrogen, for example, again, we're rounding to the first decimal place, the tens place, we have 1.0 grams, and that's 1 mole of hydrogen. And then if we look at magnesium for our last example, 24.3. So that's again, the number of grams for 1 mole of whatever element you're looking at on the periodic table. Now, if we want to be able to calculate how many moles, what's the mass of a mole of a compound, then we need to know the formula of our compound. So this is another place where knowing how to use the prefixes to do the covalent molecular formulas, knowing how to do the ionic formulas and doing the plus and the minus charge, making sure things balance. If you do not know how to write the formulas for our compounds yet, you're going to really need to catch up with that, because we need to be able to do that to do pretty much what we're doing the rest of this unit. We're going to be calculating the mass of every element and adding those together to get our total mass for our compound, and that'll be for just 1 mole of our compound. So let's do an example. We're going to do a few together, and then you'll have one that you'll need to work out on your own. We have SO3. This would be sulfur trioxide, and if we're trying to do the molar mass, we need to know the mass of each element, and then we're going to add them all up. So for sulfur, we need to look at our periodic table. We have 12.066. That's 32.066. That's going to round to 32.1. And if you look at sulfur trioxide, we only have 1 of those. So we're going to take our mass and we're going to multiply it by however many atoms of that element we have. So for sulfur, 1 atom, so 32.1 times 1. But for oxygen, we don't have 1 of them, we have 3 of them. So we're going to be multiplying the mass by 3. And oxygen has a mass of 16.0 when you round, 15.999, so 16.0. And you're going to be needing a calculator. You're going to be multiplying each of those. So we have the 32.1 from the sulfur. We have the 16.0 times 3, so we have 48.0 on our oxygen. And you're going to be adding those up. So adding the sulfur with the oxygen, and you're going to have 80.1. Now that's how many grams of sulfur trioxide equal 1 mole of sulfur trioxide. Alright, so that's called a molar mass. Let's do another one. This time we're going to be doing hydrogen peroxide, H2O2, and we have hydrogen and oxygen. Hydrogen, we have 2 of those, and a mass for hydrogen of 1.0. We also have 2 oxygens, and they each have a mass of 16.0. So again, we're going to be multiplying the number of atoms times the mass of that atom. So 2.0 for hydrogen. 2 times 16 gives us 32 for oxygen, and again, I'm keeping my significant digits because when we add Our rule is that we go by decimal places, so we need to keep that 0.0 on there as a significant digit. That's important. And again, that's how many grams of that particular, in this case it's a molecule, is equal to 1 mole of that substance. So we could use this as a conversion. Hopefully you're seeing that when something's equal to each other, we're going to be able to set this up as a conversion later and convert from moles to grams or grams into moles of particular items. Alright, PCl3. This one we have phosphorus and chlorine, and for phosphorus we have one of them. If you take a look at your periodic table, 31.0, and chlorine, there are 3 of those, and each chlorine is 35.5. So 31.0 for phosphorus, and math-wise, when we multiply chlorine 3 times, 106.5. We add those up, and again it goes by decimal places when you're adding, not the total number of significant digits. So we want to keep the 1 decimal place only. We have, that's how many grams total of the phosphorus trichloride that we had, and that's equal to 1 mole of phosphorus trichloride. Now this last one you're going to be working out on your own, but I'm going to get you started on it just because I know for some of you maybe it's been a little bit since you've converted formulas, but we have sodium hydrogen carbonate. Now you're going to be doing the molar mass of this, but you have to know what the formula is in order to get the correct molar mass, because we need to know how many of each atom it takes multiplied by the mass from the periodic table. So when we have sodium, and sodium, this should be a big clue to you right now because sodium is a metal, that this is an ionic bond. So we have sodium with a +1 charge, and then hydrogen carbonate, this is one of those polyatomic ions. Carbonate is CO3, normally with a -2 charge, but the hydrogen carbonate lowers that charge. So hydrogen carbonate is HCO3 and it's got a -1 charge. +1, -1, they cancel. They're already balanced. Having one of each is good enough. And so for the problem that you're going to be working out on your own and showing me tomorrow in class, this is the formula that you want to have, okay, that you're going to be working through. So get out a periodic table, work through how to do the molar mass of sodium hydrogen carbonate, and I look forward to seeing that one finished in your notes tomorrow.